Hello and welcome to part 2 of my Raspberry Pi solar powered weather station project. It's actually more of a update than a full part 2 because real life and work has been getting in the way of things, so I've not had much time to do any of the development stuff that I was hoping to do by now. But I have been doing some purchasing of equipment and components, and as people have been asking me what's been happening, I thought I'd do you all an update and go through the things that I have been buying. And also I've been doing some experimentation on weather sensor, which I'll tell you about, and I'll show you some of that at the end of this clip. So on with what I've been buying first. Now I have been buying a power bank, and the observant of you will say, John, you've already shown me a power bank. It was in part 1 and that was perfectly adequate. And it was, and the power bank that I was showing you in part 1 was this one. And it is perfectly adequate. It's a 20,000 milliamp hour power bank, and it will happily power the Raspberry Pi. However, there's one problem with this and most power banks, in that you can't actually charge it up and power something off it at the same time. So if you remember, what I was going to try and do is trickle charge the battery from the solar panels during the day, so it would have enough power in the cell to discharge it to the Raspberry Pi overnight. So then consequently I could have 24-hour operation. Well, this doesn't allow the trickle charging and the powering of something. It's something called pass-through charging, and this can't do it. However, this can do it. It's a Zendure power bank, and it specifically states that it's suitable for pass-through charging. So I bought this. Other than that, it's identical the same. This is a 20,100 milliamp hour, and the other one was a 20,000 milliamp hour. The capacity is the same, but it has the electronics to do the pass-through charging. So I bought this. What else have I been buying? Well, it's been a long time since I've done any electronics, many years, 20 plus years. So I've had to really start again with buying my core components. And the first thing I needed to buy was some circuit board material so that I could solder all the discrete components on. And I must say, this is very much changed since the last time I did something. The things that I bought this time are the double-sided things, double-sided boards, and these just simply weren't available when I was doing electronics at university 20 plus years ago. What I had to deal with then was sort of boards that were single-sided had copper strips on, and if you wanted to break a track, you'd have to scour the copper track out, and that's what I was dealing with then. These things are double-sided and they don't have tracks on, so you have to do a lot of bridging of the pads to get the current to flow in the right places. And for that, I have bought much cabling, single core cabling for doing those little bridges and anything else that comes across. So I bought that as well. I've also bought some of these little things which are perfect for Raspberry Pis. They have already got a little connector on the edge which will go onto the GPIO socket of the Raspberry Pi, and on the other end something that I can actually solder onto. So I'm not using them in this type of ribbon cable effect. I'm actually pulling out individual strands off them just so I can test things much easier. So that's the cables and board I've bought. What else have I bought? Oh yeah, well, because I have to start again from scratch with my discrete components, I've had to buy a kit of resistors. Now, I used to be able to go into a local electronics shop and buy individual resistors or packs of 2 or 3, but I've had to buy a box of these. They're all mixed and they're all labeled, so I guess that's something. But that's an unnecessary expense I didn't think I'd have to do. But a lot of the sensors will need resistors to get the right calibration out of them. And finally, well, not entirely finally, this is the penultimate thing that I bought. I'll show you the last thing I bought, because that leads into the testing. The last thing I bought was a project box. Now I need a project box because obviously this is going outside. So I needed something with waterproof, weatherproof protection. And this supposedly is IP66 rated. Now, if you don't know about IP rating, it's an international standard. It's called, the IP stands for Ingress Protection. And it's two sets of numbers. The first set of numbers gives you the level of protection from solids. The second level of numbers gives you the protection from liquids. So this, according to the manufacturers, is IP66 rated, which means that it does it blocks all solids from entering here, and it will do most liquids, including strong jets. So it won't allow ingress of strong jet of water or anything like that, which is fine for me because all this is going to have to do is stand outside and withstand some rain. However, there is a problem with this. I bought this from eBay, from a supplier on eBay, and it came all the way from China. And I have to say, it's not, the seal doesn't appear. I say appear because I haven't tested it out yet. That's something I'll need to test and film. It doesn't appear that the seal is perfect round there. They have these little plastic screws which go right the way down inside for this side of the box. There's one on each corner, and that's supposed to draw the top and the bottom together and house on this rubber seal which is going around it. But I don't know whether you can see. I'll try and show you the line here, which is supposed to be sealed. You see, it's sealed on the back. It's fine. It's a nice seal around there. But as you come round, you see that there's a little less of that good seal around the box here, and it looks like it's been compressed in transit, or there's been some sort of torsion force on it, and it's kind of out of alignment. And the material of the box is a very hard plastic, rather than a soft plastic, so you can't really squash that back in without it. You heard a crack there. I hope I haven't damaged it. So I'm not entirely sure whether this will be entirely IP66 waterproof, but I'm going to test this out. So hopefully it will be, but you'll hear about it in the next episode. And finally, the actual last interesting thing that I bought, or the only interesting thing that I've bought in this this section, is the first sensor that will go into the Raspberry Pi. And this is a temperature sensor. The actual exact model is, and I've got the piece of paper here, is a DS18B20 digital temperature sensor. And it goes, it's got a little, I think the only thing that makes it waterproof, you can get two types of this. The first one just looks like a little transistor. It's got three little legs on, and these are the three little legs that are on the waterproof one. The only difference I think it makes is it's on a long piece of cable, and it has a bit of a heat shrink around the end. I guess that makes the seal waterproof. But that's going to go through the project box that I showed you before, through a rubber grommet, and hopefully that will allow it to protrude outside of the box and get a quality temperature readout. Now, I have done some testing with these, and which you'll be able to see next. Actually, I've got the video for it, and I'll talk you through it as we get to it. But I have done some soldering on this, and which you'll see in the video, and just to calibrate it and make sure that it's all working all fine. And that's what I'm going to show you now. So I hope you enjoy this little segment where I go through some experimentation on this temperature sensor, and I'll catch you after. Okay, here is the little test rig that I have set up. One thing I needed to explain before I start is the orientation of the camera. I've got the camera looking from above, and I'll be working on the desk from the top of the screen, so I'll be coming in from the top of your image. Anything I write down will obviously be inverted, and therefore I will caption over the top anything that you needed to see specifically in terms of text. Okay, let's get on with it. Okay, so in the top right hand side of the screen, you will see the sensor, and this is the one I showed you before. The sensor has three wires coming out of it, and there's a red, there's a yellow, there's a black. I'll explain what those are later on. Then underneath the sensor, you'll see the Raspberry Pi unit. It's a standard Raspberry Pi B, and but it is second-hand, so I need to do some testing to make sure that the GPIO is giving out the right voltages. And in order to do that, you'll see that I have some test probe wires coming off the GPIO pins. So in the top left hand corner, you will also see a pack of 4.7k ohm resistors. I don't need all of them, I only need one, and that's for to sit in front of the sensor. I'll show you how we do that when we come to the soldering section. And finally, in the bottom left hand side of the screen, you will see a multimeter, which I am going to use to check the voltage coming from the Raspberry Pi. Okay, so this is the part where we actually map out what pins are going to where and what colors are going to where on the sensor and on the test probes. And as I said, I'll be writing all of this down. So I'll be putting, because that'll be inverted as you see it on the screen, I will caption this later on. So just to recap, this is a sensor DS18B20. It's a weatherproof temperature probe. And it has the three colors and three cables in there, and we need to couple it up with the with a 4.7k ohm resistor into the Raspberry Pi. So what we have is the pinout for ground, which is the black cable, and that for the test probes I've kept the same colors as the ones coming out of the probe. The sensor rather. We have an output, which is the data, which is on the yellow pin, the yellow cable. And finally, we have the red cable, which is the 3.3 volts from the Raspberry Pi. So translating this into pins on the GPIO sockets on the Raspberry Pi, we have pin 6 is for the ground, the black cable. Pin 1 is the yellow output or data cable, and pin 1 is the red 3.3 volt cable. Now let's get this multimeter switched on, and let's just see if the voltages match what I expect. So first we'll do the red cable, which is the 3.3 volt cable, the pin 1, and it should be 3.3 volts. So let's see what we've got here. And it is indeed 3.33 volts, which is exactly what I would hope for. So that's all fine. And if we switch to the yellow, which is the output or the data cable, that should be about 3 volts. So it's 3.16 volts. And again, that's fine. So excellent. Or we know that the GPIO pinouts in terms of voltages are working fine. Okay, so this is the part where I make so many mistakes you will not believe when we're starting to do the first lot of soldering. Now, as you can see, I've got in my hand a 4.7k ohm resistor, and I'm making such a palaver of all this. But ultimately, you can see immediately that I've still got the Raspberry Pi switched on. Obviously, if I'm going to start connecting stuff together with the Raspberry Pi and doing any sort of soldering, it'd be brilliant if we could have that switched off. Don't worry, in a minute, I think I do remember to do that. So I'm just sorting out some solder now, and just taking off the crocodile clips, switching off the multimeter. Oh, so I'm really, really serious now. Whoa, look how serious I am. I'm doing all of the stuff, all of the proper prep. Still haven't remembered that the Raspberry Pi needs to be switched off. Getting the probe wires ready. Yeah, doing all the professional stuff. Yeah, trying to get the ground out of the way, ready. I'm just going to be doing the 4.7k ohm resistor has to go across the 3.3 volt and the data out cable. For this point of the video, all I'm going to do is actually just solder across the resistor. I'm not putting it on any circuit board or anything. I'm literally just going to solder across a resistor with perhaps a little bit of heat shrink to stop any shorting out, because if we short out these cables, then the Raspberry Pi will just reboot itself or might even damage it. So soldering iron at the ready. You see, I'm already ready. I've got a soldering iron and it's already hot. And when do I realize that I have to switch the Raspberry Pi off? Oh, have I remembered? Yes, I've remembered it now. I've literally just unplugged it. And the Raspberry Pi has gone off. So I'm doing some tinning on the edge of on the ends of the probe cables. These are quite actually difficult to tin. Now you immediately see that I have a problem because I don't have any helping hands mechanism to clip this in place. So I'm doing a terrible job of getting these tinned and the soldering done. And in a minute, I'll come up with an ingenious method of how to do that. But at the moment, I'm still just being cack-handed. For those of you not familiar with the term cack-handed, it just means somebody who's absolutely inept. Yeah, this is quite embarrassing now, really. And you know, I could just let this go on for a long time, trying to do this soldering. Oh, now I'm deciding to balance it on top of the roll of solder. This is not going very well. Oh dear, this is really embarrassing to watch back. Okay, I'm going to put myself out of my misery, so I'm not embarrassed any further. And then I'm going to take you to the bit of the film where I do, the bit of the video where I do actually work out how to solder this properly. Okay, so we move on to the video a little bit further on, and I've got a bit further on with the soldering, but I'm still making an absolute terrible job of it. So in a little bit, I come up with an ingenious way of doing the soldering, whether there's nobody else around to hold on to the cables or you don't have a helping hands unit, and that is to use the wonders of Blu Tack. And once I came up with this, it was much easier for me to do it. So I just stick the two ends that I'm going to solder together reasonably close to each other, and then the rest of it all comes quite easily. Well, I say quite easily. That solder has obviously failed. But in terms of holding things steady, it's great. Nice shot of my head there. And we're very, very close to where I wanted to be be honest. We do have the resistor across the out and the 3.3 volt. We do have the ground, which I'm soldering up to the last ground wire on the sensor, and then that is pretty much it. It's all done. Like I say, this is not how it's going to be in the end product. This is just so I can perform some sensor calibration tests, and I'm going to show you those next. Okay, so now we have the final rig. The sensor is soldered onto the test probes. The resistor is across the yellow and the red wires. We have the sensor in place. We now need to put a little bit of code in Python on the Raspberry Pi. Now, I'm not going to show you how to do that here. I do have a GitHub repository which I will put in the description, and that will have a README and all of the code necessarily. I will show it briefly on screen. If you want to, if you're interested in this stuff, you can always pause it, but getting it from the GitHub repository is far the better option. And now we go on with the actual test. So we've booted up the Raspberry Pi. We have the code running. To do the test, we will have two extremes in temperature, and for that I've got some ice packs and some warm water. I don't think it's hotish water, tepid water. So we can show when we put the probe into either how the temperature fluctuates. And to do the last part of the test, we need to flip over into the screen mode. So we need to see the Raspberry Pi screen, and we're going to run the Python code that I showed earlier once I get my typing correct. There we go. So what it's going to do now is just a simple take a snapshot of the temperature through the probe and run it in a loop, and then print. So you're taking a snapshot of the temperature in Celsius and then printing to the screen, and then taking another snapshot and then printing it to the screen, and just doing that in a loop constantly. So you'll see that the cursor is now moving down the screen. What you can't see very clearly is that the temperature's actually being shown on the screen at the moment. It's about 16 Celsius, and 16 Celsius is ambient temperature within the room that I was testing this out under. And .75, I think it is at the moment. Yeah, that's what it is. So that's, like I said, that's ambient temperature of the room. And then what we'll do is, what I'll try and do is now I'll try and affect that temperature to see if it rises or falls. So the first test is simply to grab a hold of it with my hand, the temperature sensor. Just reposition the camera somewhat so you can actually see this. And then when you'll be able to see it, I'll start holding the sensor off camera because it starts moving straight away, the temperature. So I'm holding it now, and it's immediately up to 20 degrees, 21 degrees, 22 degrees. That's just my body temperature that you're seeing there, the change from the delta change from the 16 degrees, which is ambient temperature, and the additional increase in temperature is my body heat. So, and then what I'll do, I think you'll find that once you remove the heat source or the source of cooling, it does take a little bit to return again down to the ambient temperature. So you see now it got up to about 27 degrees, but when I remove the heat, it's taking much longer to go down to the 26 degrees, 25 degrees. Still on 25.2, 25.1. Yeah, so the system response is not immediate. $24, 23.9. So I'll let it flatten out for a little bit before I do the next test. Back down to 22.7, but not yet at room temperature. I think it's nearly dropped down enough so that I can consider doing the next test. Down to 20 degrees, 20.8, 20.7, etc., etc. Nearly hovering about 20 degrees. It just dipped below the 20 degrees now, 19.8. So as you can see, it started off at 16 degrees. I placed the sensor in my fists, so we've got the body temperature rising, but it takes a long time to go back down to the standard ambient temperature of the room. I think they call this critical damping, and I think there's a coefficient involved. I can't remember. I'm trying to go back to what I learned in engineering, but it is taking a long time, so that coefficient, that damping coefficient, is quite high, I believe, or is it the other way around? Can't remember. You best look it up if you're interested. So 18 degrees. $18 degrees. Below 18 now at 17.9. So we're very nearly back to normal ambient temperature within the room. 17.6. And now I've got the temperature. I'm confident that that's down enough. I'm now going to put the temperature probe into the ice pack and leave it there. And I expect this for to start dropping off again quite quickly. Yes, now it's down to 14 degrees, 13.6, 12.9, 12, 11. So obviously it's an ice pack here. So if the calibration is pretty much correct, then I would expect this to be down to around, if not exactly, at 0 degrees, because it is frozen, and that's what I'm hoping to be able to ascertain from the sensor. So already we're at 10 degrees. I'm just desperately trying to find the right place where I can just keep it in there and not affect it with my body temperature at all. So I'm trying to hold it into the center of the ice pack. Yeah, so this is down to 8 degrees now. So and it's we had a plateau, but it's dropping again, 8.6. Just dropping below 8 degrees now, so under the 7.9s, actually 7.8s. So I'm happy that that is successful. It's dropping down quite well. And now I'm going to put it in directly into the warm water, the glass of warm water, or tepid water as I decided to call it earlier on. And immediately, whoa, straight up. It's obviously more hot than tepid, I think. We're already at 25 degrees, 26 degrees. And the screensaver kicked in there. 30 degrees, whizzing up. So that's about the sum of the testing. I'm happy that pushing the sensor in cold things reduces the temperature, pushing it in hot things increases the temperature. Let's see if I can get it back down again by putting it directly into the ice pack again. I want to return it to ambient temperature of the room. Already plummeting, 18 degrees, 17 degrees, 16 degrees, 15. So we're past ambient temperature of the room. Obviously, I'm now going to try and take this down towards freezing. Nine and a half. I've obviously got it in a good position now because this is dropping quite quickly, which is what I was hoping it would do. Small little plateau there at around 8 degrees, but then dropping again to 7.5. Still dropping. In the 6s now. Now, as it gets towards 0 degrees, where the temperature of the ice pack is, I expect it to start plateauing out, and the last bit of the temperature drop will be much, much slower. So already now we're having quite a few around the 6 degrees mark, around the 5 degrees mark, just dipping below 5 now. But when it gets to the 2s and the 1s, I expect it to be quite slow. And in fact, we're seeing a lot of temperature readings which are very similar. So we're at 4.75 twice, 4.625 twice, 4.6562 twice. This is all as expected. We're still in the 4 degree region, which is spending a lot more time there than it has been in only the previous temperature readings. So yeah, back into the water again, the hot water. See how quickly I can get it up there. Again, it does that major that delta changes. The initial delta change when you put it into hot water is quite dramatic, from 6 degrees to 14 degrees. Now it's already at 28 degrees. The change from cold to hot is much quicker than from hot to cold. Already in the 30s. And I'm fairly satisfied that those tests have been successful. So ice makes it tend towards the 0, and the hot water, it wasn't anywhere near boiling, so it's not going to end up in the 100 degrees, but it certainly goes up towards the higher end of the temperature scale. And with that, I think I'll leave the tests for this time and hand it back over to myself to sum up. Well, I hope you enjoyed that part 2 update on where I'm going with the Raspberry Pi weather station. And I hope you enjoyed the little film of me playing around with the temperature sensor. Next time, I'm hoping to get into more of the electronics and perhaps even a bit of coding in Python to try and start bringing some of these sensors together. Hopefully I'll bought more than one sensor by then as well. And I'll also be going through things like how to measure where I'm going to put things in the box, make sure that the box is in fact waterproof, and a few other things that I need to confirm before I go to the full project. So like and subscribe if you enjoyed this video and you like sort of stuff like this, and also click the little dingy bell so you'll get notified when the next episode comes up. So I hope you've enjoyed it. Stay tuned for next episode, and see you around.